Okay, so remind me of some of the things that we did last year with triangles. What do you know? What comes to mind when I say triangles? Okay, so give me some, okay, what's that? Okay, so Pythagoras. We need to use, I can't write and say Pythagoras. Okay, Pythagoras, we're going to be using that. What else do we know? Okay, good. I'm going to start with the easier stuff. SOHCAHTOA. When do you get to use SOHCAHTOA? Right angled triangle. We have sine and cosine rules. When do we use those? Non-right angled triangles. You are definitely going to be using these today. How do you find the area of a non-right angled triangle? Half AB sine C. We did that one already yesterday. You're going to need that again. I think those are the main things that you're going to need to remember. So if we're breaking up, so like we were doing yesterday, if you have sectors of circles and then you have a chord that joins the two radii, you are going to have triangles and they are going to be non-right angled triangles. So thinking about our circles, with that, wonderful. Yeah, happy with that. I got no problem with cheating. All right, so if I give you something like this is a non-right angled triangle, right? I'm not necessarily going to tell you what this is. What do you know about these two sides? They're equal, right? This is an isosceles triangle. It has to be equal in size. If I wanted to do something that would make my life a bit easier, what else can I do with an isosceles triangle? Cut it in half, and that gives me, right, always gives me two right-angled triangles. You do not always need to break it into two right-angled triangles. If you've got enough information just to do the first thing that occurs to you, great, go for it. You might just be able to use a cosine rule or a sine rule, depending on what you get. But if not, you can break it up into extra right-angled triangles if you need to. There's usually more than one method to solve some of these. And it's really up to what information you can pull out as to how easy you can make it for yourself. If you forget about, some people just go straight for the hard stuff and forget about the easy things. What if I gave you something, I'm just going to use a different color. So what if I drew a line through the center and then I had a point on the circle and I made a triangle? How do you know that? Yes, that's true. So remember, any line that is a diameter will always create a right angle wherever it hits the side. If I make it here, it doesn't matter if it's in the middle. If I was good at drawing, this would still be a right angle. So always think about anything you already know that you can add to geometry to give you extra pieces of information that will make your life easier. All right, let's try and put some of this stuff together. So let's do a couple of examples. All right, so actually, I don't want to do that. But you're right, I should. I'm just so dodgy at drawing. Okay. Just let me be rubbish at things. Okay, actually, no, I will use a circle.
You've already drawn it.
Shut up.
You just made a circle around that.
Okay. All right. So. Okay, what do you know? These lines are called what? If I'd drawn it better, tangents. What do tangents always make with a radius? Right angles. So immediately we know that these are right angles. Okay, that's helpful. Obviously, I've got a pretty dodgy drawing here though. Okay, I'm going to tell you that this angle is 2 pi over 3. All right, and I'm going to tell you that this is 20 centimeters long. So I now have some information. What do you think? Actually, I'm going to color something in first.
Here.
Let's color. Yeah, well, actually, let's color in a different color. Right, so I want this section here. Okay, So what I've got is I've got enough information to break all of this up into smaller, easier things. I know this is already a sector. Don't I already know how to find the area of a sector from yesterday? What is it? Okay, right? Isn't it just r times the angle? So it's just 20 times 2 pi over 3. Okay, which gives us 40 pi over 3. Sorry. I still didn't hear anyone. That's arc length. You're right. Oh, look at me doing it wrong. That's arc length. What do we want? Area. What's the area one? Good. Half r squared angle. So we've got half 20 squared times 2 pi over 3. All right. So what's half of 400? So it's 200 times 2 pi over 3, which is 400 pi over 3, right? Think of this as being over 1 and you multiply straight across top and bottom. So that means the area of the sector is 400 pi over 3. Don't I just need to subtract that from the area of the whole thing? Yeah? Okay, so let's think about what can I do with this to get the area of my full shape? Yeah, good. I'm going to make a line down the middle and turn this into 2 right-angled triangles, right? So if I've got this, I know this side. Do I know this side? Nope. Do I know this side? Do I know this angle? What is it? It's half of this. It's pi over what? It's pi over 3, right? 2 pi over 3, so we're halving it. So that means if we want the area of this, this is, well, we don't really know what it is at the moment, do we? So what are we going to do? I mean, first of all, let's just say that the angle is pi over 3, right? Just to make our lives a bit easier. Then what am I doing? I can do SOHCAHTOA, can't I? Good. So what am I going to do? Yeah, I'm trying to find this one here, which is my opposite side, isn't it? So am I using sine, cos, or tan? Tan. This is my adjacent, isn't it? Isn't this my hypotenuse? I'm not using my hypotenuse. I'm using my adjacent and my opposite. So I have tan of the angle. Whoops, that's not a 3. Is the opposite, which I don't know, over my adjacent. So isn't it tan times 20 over tan pi over 3? And if you type that into a calculator. All right. Now, you are going to be wanting to use exact answers. All right. So no rounding to decimals. My side length here is 20 root 3. That is 20 root 3. Don't give me a decimal approximation. For this entire topic, don't round unless you're told to. If you're asked for exact answers, stick to it. If they ask you to round, great, go for it. If they don't tell you, it's best just to leave it in exact form. To find the area, right? It's half times base times height. Exactly, but you're going to have to do 2 times half times base times height. So why not just do base times height, right? So for the area, we're going to do 20 times 20 root 3, which is? No. 400 root 3, right? We're leaving it in exact. Remember, this is the same as 20 times root 3, right? Isn't that what this is saying? Good. Then we're going to take this and subtract this because we only want the shaded bit. So then I've got 400 root 3 minus 400 pi over 3. And if I type all of that into a calculator, well, I'm going to get, I mean, basically that, right? So 400 and then root 3 minus pi over 3. Why is that so annoying? Minus pi over 3. I'm just taking out 400 as a common factor and writing it like that, but you can't get any simpler than that, right? So this is the area of the shaded region of that shape. So there's a lot of work to do, but it's really just about doing one thing at a time. What do you know? What information is available to you? Again, if you wanted the perimeter of this shape, you could then find the arc length. So let's do that. This arc length, we just tried to accidentally do it before, didn't we? So it's r times the angle. So it is just 20 times, what is it, 2 pi on 3? Which is 40 pi on 3. So that is this. And then we just add these two sides, which we've already worked out, right? So then the perimeter is 40 pi over 3 plus 2 lots of 20 root 3. So then we have 40 pi over 3 plus 40 root 3. And again, I could take 40 out as a common factor. So then I've got pi over 3 plus root 3. And this is the perimeter of the shaded area. Does that make sense? So we just break it down a little bit at a time. Let's look at something else that, again, looks pretty complicated, but isn't as bad as it looks when you just break it down into a section at a time.